All right, ladies and gentlemen, thank you so much for joining us today. On behalf of AVSI, I'm pleased to welcome you to today's webinar, Future-Proofing Your Airspace Visualization. My name is Keely Griffith, and I'm the Vice President of Strategic Programs here at AVSI and your host for today's webinar. Before we get started, I have a few housekeeping items to note. As always, all participant lines will be muted during today's webinar. A recording of the program is in progress, and a viewing link will be emailed to all attendees along with a copy of the slide deck within the next week. You can now view all of our webinars on AVSI's new learning and engagement platform, AVL. If you're listening to the broadcast and you need assistance, please send a note to the webinar leader using the chat at the bottom of your screen. Please note that any links featured in the slides will be shared through the chat during the presentation. After the presentation concludes, we will open the session for Q&A. Attendees, you're encouraged to submit questions at any time throughout the webinar using the Q&A button at the bottom of your screen, but questions will only be answered at the end of the presentation. Please note this is a different box than the chat, so please submit all content questions using the Q&A, which can be found next to the chat. So let's get started. We'd very much like to welcome back and thank our sponsors at Kongsberg Geospatial for their support today. It's always nice to see a familiar face. We're excited to have two excellent speakers with us today. First is Paige Cutlin, which many of you know is the VP of Sales and Marketing at Kongsberg Geospatial. And joining him is Yoav Amitai, who is the CEO at Elsight. We'll start today's program with Paige Cutlin. Paige is currently the Vice President of Sales, as I said, and he joined the firm in August 2014. Paige has been in industry since retiring from the Canadian Air Force as a major in 2000. Paige flew on the Canadian CP-140 ASW aircraft as a tactical coordinator and mission crew commander. His last posting in the Air Force was to Air Strategic Plans, formulating the initial Royal Canadian Air Force requirements for the Justice Strategic UAS capability. Paige joined industry in a project management role and has been directly involved in UAS program delivery and sales to various federal government departments for over 15 years. He's a graduate of the University of Manitoba and the University of Ottawa for his MBA. We're certainly in great hands. So with that, I'm going to hand things over to you, Paige, to kick us off.
Thank you very much, Keely. And thank you everyone for joining us this afternoon. What we're going to talk about is a couple of foundational technologies that can help you future-proof your future airspace visualization and operations. So what I'll do is just find my page down control here. Bear with me. So stand by. Oh, there we go. So the premise of our presentation today is that there's a lot of technology and technological change expected in the drone space over the coming years, but there are foundational technologies available to you that can de-risk the future, that can allow you to be pretty safe in your technology choices while other technologies continue to change. So we're going to talk about two of those today, our Iris product line from Kongsberg Geospatial, and our partners and friends at Elsight are going to talk about their technology capabilities. So I'll first introduce Kongsberg Geospatial. I'll talk about Iris Terminal and Iris GCS, show you a couple of videos, and then I'll introduce Yoav Amitai from Elsight, who will talk about their product lines, and then I'll close with a few words on how this will enable you to future-proof your connectivity and your airspace visualization. So at Kongsberg Geospatial, we have a technology and product line we call Iris Terminal, which is an airspace visualization and control solution. And where Iris Terminal comes from is a background of technology based on a map engine product we have called TerraLens. And this is a very high performance map engine that's used in a variety of airspace visualization applications that you can see here on this slide. So it's used by civil air traffic control for their operator displays. It's used in surveillance aircraft for their operator displays. It's used in surface-to-air missile systems, which again is an airspace control application, and in things like remote air traffic control towers and the Triton control station. So it's an airspace visualization pedigree in our company that we applied to the drone and commercial UAS space. So the goal of what we're doing at Kongsberg Geospatial is to try to combine and correlate and present a lot of complex data feeds to make it easy to understand and interpret for the operator. So within Iris, there's a lot of different types of data feeds some are very static, like 3D terrain data. There are some that update regularly, like aeronautic data, and there are others, and just bear with me here because, so as I was saying, what we're going to talk about today is some foundational technologies that will de-risk your technology path. And I'm going to talk a bit about Kongsberg. I'm going to introduce Yoav from Elsight, and in talking about Iris Terminal, which is our core technology, it's based on some aerospace and aviation visualization technologies that I briefly mentioned, but you can see now here in the pictures. And basically the goal of Iris is to combine and present a variety of static and dynamic data sources to allow for interpretation by an operator. So there's static data, there's periodic aeronautical data updating every 56 days, there's live data from sensors or weather feeds, and then there's your own fleet data, your own aircraft position. And with all that data into Iris, we can provide services like collision avoidance. So in this chart, you see sort of a architecture view and the various sensor feeds we bring in on the top left, the various services we can provide bottom left. There can be any number of operators, and then through technologies such as Elsight, we can communicate to any number of drones to provide that many-to-one capability. So what we're trying to avoid is this kind of occurrence, which shows an ATC operator where every new data feed or sensor seems to result in a new display, and all of that correlation and fusion is done in the operator's head. So the goal of Iris is, as we embed new technologies within it, is to reduce the cognitive load of the operator by providing an increasing level of decision support to allow them to manage that many UAV to one operator situation. So I'm going to show you a couple of videos that'll hopefully run. So I'll start with this intro into some of the Iris UI and some of the capabilities. So hopefully you're seeing that. So you're seeing the UI, there's different layers we can enable. On the left, you see the 3D view with airspaces were turned off. You can see the sensor footprints. You can do the following of the drone, which is the yellow vehicle there on the display. You can see there's a loss of separation has occurred and is being alerted to the operator. So we've turned off the sensor footprint so you can better see that we're indicating when that closest point of approach will be, what the current horizontal and vertical displacement are of the two vehicles. There's an audio tone that you would be hearing here, but it really helps, you'll see in the 3D, to understand that difference in separation as the two vehicles approach each other. And then on our flight plan route, which is the light blue, you'll see we're about to execute a left-hand turn, and this predicted loss of separation will disappear. And that just occurred there. And the alert has gone away. So I'll stop this video. You can see we're bringing in the VNC, VFR navigation chart in the viewport there. You can vary the backgrounds of Iris. So just let me go to the next video, start that for you. So this is, again, just showing some of the different features in the UI, which is platform and autopilot agnostic. There's different views you're bringing in. On the right there, you're seeing there's internet web-fed weather, different backdrops you can have for the 2D view, turning those on and off. It can be macro weather or micro weather through our partners. Now you're seeing, as we zoom in a bit, within the airspace structure, which we'll turn off there, we have a flight underway, and this is our local detect and avoid sensor coverage. So green is indicating Echodyne radar coverage, and red is iris automation, both sensors that we've integrated into Iris. So you can see the operator resizing their viewports here to set it up the way they choose. There's other features or viewports you can bring in. So here's an example of a PDF, which could be a checklist that you could bring in for the operator to view. We're closing that viewport. You can maneuver your 3D viewport, and we'll shortly see again, another loss of separation event. You can change the map underlay to your view. There's different sensor modes that you can turn on or off and show a correlated sensor view if you have multiple sensors of different types, ADS-B and your own telemetry. We could do all of that correlation to only present a single track to the operator. So here's a predicted loss of separation. One of the sensors has picked up a non-cooperative track. We've acknowledged the alert. You can see that we're depicting to the operator the horizontal and vertical separation and the time to that loss of separation. Another feature we're currently developing with a client and demonstrating for their test is a suggestive avoidance feature. So in addition to presenting the detect and avoid information, we would show what the recommended avoidance action is for the operator. So now if I could introduce Yoav Amitai from Elsight, I will turn it over to him to talk about their connectivity, which has been integrated with Iris. And I'll turn it over to you, Yoav.
Thank you very much, Paige, and hi, everyone. Nice to meet you all. My name is Yoav Amitai. I'm the CEO of Elsight. And what I'm going to go through with you is one of the components that Paige mentioned as part of what he said is about having real-time data coming from the field and how you do it in a reliable way. But I want to start in a little different place of what BVLOS is when we're talking about BVLOS and what are the main challenges when we're talking about BVLOS. So that's a small slide showing what are the different, not only distance, but different types of operation: visual line of sight, extended visual line of sight, and beyond visual line of sight. And those definitions varies between different regulators worldwide, but some of them are pretty much the same. So there are two main elements distinguished between the visual line of sight and beyond visual line of sight, and extended is somewhere in between. So it's not only about the distance between the operator and the drone or the platform, it's also about how many different platforms a single operator can operate. So if, for example, you have a single operator operating one drone within very close range, like 100 or 200 feet or 400, even 400 feet, it's still within the line of sight. But if we'll have the same operator operating two drones or more than that, that will become a BVLOS regardless of the distance. So it's not only about the distance, it's also about how many platforms a single operator can do. And we're talking about something that is still don't have the actual framework, let's say, or the fully defined framework of where we at in terms of regulation, but in terms of the technology that it's required to be able to operate those kinds of operation, that's start to be clear of what it's needed and why you need to operate, or what are the best practices to operate. But before that, a little bit about the BVLOS. So when talking about BVLOS, we at Elsight, together with Kongsberg and in general, parties that are part of this ecosystem, thinking how to get this drone ecosystem to the maximum capability, to the maximum place when we can be at the top. So in our view, in LSI specifically, in our view, BVLOS, it's one of the major components to go there because there are multiple measures that will bring us there. First of all, so the reason we need BVLOS is, first of all, from safety measures. So when we have humans, we usually have places that mistakes will happen because we're all humans, we all do mistakes sometimes. And when it's not, when we're taking the human out of the loop, this or another, or we are reducing the amount of work that the human needs to do inside the loop, that creates a much better safety measures, and we can work more safer like that. From in terms of economy and economy of scale and how do we take it, so it's exactly the same. Again, it's all about how to take the human outside of the loop and making sure that we are optimizing what we do, because if we're looking on multiple use cases, regardless of the application, labor, it's a major part in the cost structure. If you want to make it economically viable, we need to think how to reduce the cost of the operation and provide more value to the end customer or the end user who is using the platform, again, regardless of the application or the use case. Speaking of scalability, again, as a single operator, if it will always be a single operator operating a single drone, that's something that will be very hard to scale, because that, first of all, from economical standpoint, but not only that, also from the number of people that will need to have involved as part of this operation. So if I'm putting everything together, let's create the picture of how we grow this industry to the maximum, which again, like I said, as we see it in Elsight, is going through having a safe, reliable BVLOS operation, by that getting the drone industry or the drone ecosystem in general into its full potential. A little bit about the challenges that are part of the BVLOS. When we're talking about BVLOS, what are the main challenges? Part of them, Paige also mentioned in his presentation, but we're talking about the airspace management, the autonomy, and the connectivity. And part of what Kongsberg do as an example is provide the full picture for the operator to be able to see everything and to manage everything from a single point. And with all these different systems that are available and the operator needs to have, needs to be aware of. So that's exactly what Kongsberg's system is doing. Elsight part is the connectivity part from all those three elements. And the connectivity is so crucial, because even if we're talking about autonomous era, when everything will be autonomous, we'll still have to, eventually have to have always the human in the loop in terms of monitoring. So be able to know what the status, just like the demo that Paige just shared, what is the status, what's happening in the field, how it's look like, what needs to be done to make it safer or to get the right decision. And connectivity is a critical element of it. And that's what Elsight is doing. We're doing what we call connection confidence, making sure that you will always be connected to the platforms that are deployed out there, regardless of the distance, regardless of the number of different platforms, drones, etc., that are connected to the control room. And that's what we're doing in this case. And when we're talking about connectivity, there are multiple options that you can choose when you are start working. One is a point-to-point RF, proprietary RF, which is obviously not for BVLOS because it's limited by range, and it has some other challenges when we're talking about BVLOS. So, but it's still one of the alternatives that we have. Think about deploying a massive infrastructure across the nation, across the country, and be able to communicate like that. That will require a lot of capital investment, capex investment, but it's still one of the options. The other one is the satellite communication, which again, it's have really good coverage everywhere, but it's have its own pushbacks, which the first one is the cost of it. If we're doing everything on the satellite communication, not only the telemetry or the control, but also the sensors, that can become very expensive, very fast, which, going back to the point I mentioned before, we need to make it economically, and that can prevent us from getting there. But not only that, also if we are talking about the actual hardware that is today available in the market, so it's mostly relatively heavy product, both the antenna and the modems, heavy and big in size in terms of real estate on the platform. So it's stuff that really hard to integrate on the medium to small size drones that can fit only for big UAS, which is not all types of UAS can carry those weights, and that's again putting the price aside. And the last option is that public infrastructure. We're talking about cellular infrastructure that is very widely deployed across many parts of the world. If we're looking on the populated and semi-populated area, according to different analyses, today the cellular covering something like 87% of the world in terms of infrastructure, which is very good deployed, and it brings us a very good infrastructure to build our use case on, because it's there, it's available, we're getting a decent performance from those networks, and those networks become more and more reliable. But still, when we're talking about public infrastructure, we need to think, what are the best way to utilize them, or what are the challenges to use there? So our solution, Elsight solution, is kind of combining all those solutions, all those options that you see here together, but I want to focus on the public infrastructure, specifically about the comparison between working with a single SIM with a multi-SIM solution. A single SIM means like we all have cell phones. When we're driving the roads, we sometimes have some glitch in the call, or the video is not working very well. That's something that is okay for phone calls, because worst comes to worst, we'll hang up this phone and we'll continue the call once we have communication back. But when we're talking about real-time monitoring of controlled systems, we cannot afford any downtime or very, very little downtime. So we need to statistically see how we increase the reliability and how we make it more reliable and more safer. So if we're talking about single SIM cards, we're exposed to a single operator with his coverage, with his operator coverage. And even if we have a really good coverage when we are talking about moving platform, there is hopes between different cells. There are stuff that are happening when the drone or when the platform is moving, and that makes it very challenging to keep the call all the time in a high, or to keep the connection in a high quality of service, to be able to deliver back all the telemetry, sensors, obviously, and everything else that needs to be connected with. So that's the single SIM. On the other hand, if we're working on multi-SIM solution, which is not failover between the SIM cards, but a solution that works at the same time with all different carriers, for the example, in the US, working with Verizon, AT&T, T-Mobile, US Cellular, all of them at the same time, or any other operator, and being able to have those overlap between the operator, that statistically put us in a much better place in terms of the reliability of the network and the availability of the network. And that's how we do it, and we call it connection confidence, basically making sure that you'll be connected. I'll play a short video just to share with you how it's looked like, and I'll continue right after that.
The drone market is expanding as industries develop use cases to take advantage of drones' flexibility, mission agility, and cost benefits. But maintaining communication between drone and operator is an enormous challenge, especially over long distances. In fact, it's virtually impossible to control drones beyond the visual line of sight. RF is limited in range and reliability, satellite communication is costly and limited in bandwidth, and using just one SIM card lacks the redundancy and coverage required for safe BVLOS operations. That's why we created Halo, our next-generation communication platform, providing superior always-on connectivity and solving the BVLOS challenge once and for all. Halo bonds multiple communication links from different carriers, combining ultra-low latency with high bandwidth, enabling seamless transmission of data. The Sixth Sense algorithm encrypts the data, splits the data into packets, prioritizes, and transmits it through a secure network tunnel. Halo automatically detects failed communication channels, instantly transmitting the data on an alternate link without the disconnect caused by traditional failover. Halo aggregates 4G LTE, 5G, local RF, satellite communications, and mesh to provide the ultimate connectivity solution. With BVLOS architecture tailored to unmanned operations, Halo enables simultaneous operation of numerous drones from the same control center using Elsight's cloud management platform. Additional flight-related features include mapping and route planning, native Mavlink support, and ASTM compliant broadcast and network remote ID capabilities. Join the dozens of global partners already using Halo to propel their BVLOS operations forward. Elsight, a new era of connectivity.
So, like I said before, we are working with partners like Konigsberg to create the right solution for BVLOS operation in general. And today, in terms of deployments and what we have worldwide, so we are deployed literally in every continent in the world. Have both operator and platform manufacturers that work with us to integrate the Halo or our solutions into their day-to-day operation. And we're not only see our partners as a vendor-customers relationship, we're looking to expand because we understand that we're not the smartest people in the world, and we want to get a lot of feedback from all those deployments, understand how we can provide more value to our customers and how we can develop it again and again to many new directions, which are not only in communication, but in other places. And those kinds of partnership that we have, that's what set us forward. And just another short video showing one of our customers, specifically this one in Sprite in the US, speaking about the device and how the Halo helps them with their operation.
Sprite is a commercial drone operator that's really focused on beyond visual line of sight flights. We're focused on operating not only on the utility side, but on the healthcare side for beyond visual line of sight B2B missions for healthcare. 90% of what we need to operate in is over 20 miles. So being able to connect to multiple networks along the way is really what enables us to execute our mission. The Halo by Elsight is a perfect example of a solution that is mature and has been designed for this type of use case. Being able to operate beyond visual line of sight comes with a very complex set of waivers and exemptions and process and procedures to be able to execute that mission safely. As you can imagine, transitioning a large distance of space, we have multiple networks that we'll go in and out of. And so not only the hardware, but the software managing those networks and managing the connectivity for the aircraft so that we always have connection when we're flying it is really what enables beyond visual line of sight for Sprite.
So today, the way our experience today, we're accumulated with all those partners, hundreds of thousands of flight hours with different platforms in different terrains and environments. And it's get us to the understanding of what are the requirements for BVLOS, and that's where we are focusing, again, for the reason I mentioned before. And we're really happy to collaborate with companies like Kongsberg to provide more value in the end of the day for those operators or sometimes the platform manufacturers to take this industry forward. With that, I will hand it over to Kelly to probably the Q&A session. So thank you, everyone.
Awesome. Thanks so much, Yoav. I am going to open up the session for audience members to include Q&A. Please remember to use the Q&A feature at the bottom, which is next to the chat. You can just type your question in and hit the submit button located next to this box. And I've already seen some come in. So we are going to start the session with, why is the Elsight solution different from any other multi-SIM connectivity solution?
So there are not, thank you for the question. There are not many multi-SIM solutions that are really doing aggregation, which means that keeping all the SIM cards, all the operators in real time live and working with all of them, not only to provide better reliability, but also to provide better bandwidth to allow more data to flow through the tunnel. Let alone in the drone industry, that's even harder because you need to create a lightweight solution, lightweight both in terms of weight, power consumption, heat factors. So that's where we thrive basically to provide the best solution for this market. And today, as far as I know, I'm familiar with, that's the only solution that is purposely designed for those kind of application, for the drone application, which means that we're constantly developing more and more capabilities and features specifically for this environment. And that's before I'm speaking about the performance we're getting. So that's what I would say, that's what makes us different than all the other communication solutions that you can find out there.
Right, that's perfect. Thank you. Does the conflict detection utilize the ownership flight intent to predict loss of separation?
It does. What we're using is the predicted trajectory of the aircraft. So regardless of what your flight plan route might be, we're computing that loss of separation based on your current trajectory. So when you change your trajectory, we can compute that you no longer have a predicted loss of separation.
Thank you, Paige. Can you talk about the third-party service provider certification process, if started with an aviation authority or air nav service provider?
I'm not sure who that's aimed at, but certainly from the Kongsberg point of view, we've been engaged in various programs and projects with ANSPs that require design assurance. And that's usually part of the software development process where that entire system at the end is going to get certified to a certain level. So we have to incorporate a lot of processes and documentation into our software development to ensure that the requirements are documented and all of that traceability from the requirements through to the testing, so that we can provide the documentation artifacts to the regulator who's doing that certification. So it's certainly part of what we're used to doing with our various military and air traffic control programs. And I would imagine from your point of view, they undergo something very similar.
Yeah, absolutely. Exactly the same, like you mentioned it. We're building those systems to be certified capable, let's call it, with all the measures that Paige just mentioned. Again, I'm not sure which exactly service certification service the person who asked the question meant to, but that's exactly what we're doing as well on our side.
Okay. And I will say that for the individual who asked the question, if you want to include additional context in the chat, then I can pass that along. Another question came through. Are you integrating with any North American airports?
Well, when you say airports, we've certainly done a bunch of counter UAS airspace visualization trials for critical infrastructure, which is often an airport. But our target market are those drone operators per se.
Okay. Does L-Site, and Yoav, I think this is for you, does L-Site provide a solution for remote ID?
Yes, we are. Part of what we're doing, like I said before, we are providing, on one hand, we're providing a communication solution, which that's our core technology, but we're also looking on what are the peripheral value that we can provide to our customers to save or to not using too much hardware on the drone. So yeah, part of what we've done is to certify or to go through the remote ID requirements, both in the FAA and the EASA. So we're ASTM, based on the ASTM standard, and today it's part of our offering with the same communication link. Basically, you get 2-in-1. So the communication link on one hand, and also the remote ID that is required for flying in drones today.
Okay. Okay, another question came in, and I don't know who it's directed to, so whoever wants to jump in. Is it applicable to every drone on the market? And I assume it, right?
I would say maybe I'll answer it for both of us, Paige, and pardon me if I'm mistaken or something, but exactly this, our collaboration together is exactly how it can fit to any drone, because from one side, the Halo device can sit on the drone itself, and then it automatically can be integrated into the Kongsberg platform. So the answer is basically yes, it can fit into any drone. And then once it's there, we have everything that it's required to connect it to the other systems as well. And that's exactly what the value of this collaboration, to have it for any operator, as an example, that wants to have a fleet of drones with various types of aircraft, because for different types of missions, he can have kind of standardized solution or tech stack that just need to put it on the drone regardless of who is the platform manufacturer. And then you can work with the Kongsberg platform, and that's how it's all connected together that's exactly what we're doing with part of our value to mutual value.
Okay, great.
Yeah, and I would just echo and add to that, full agreement in the sense that there are drone solution providers now that use different types of aircraft for different missions and different use cases. So what our operator display allows is that they can use that common operator display and common connectivity means through L-Site, regardless of the type of drone they're operating. So it lowers their training bill, it lowers their technology bill, it future-proofs their solution because next year they'll be using different drones again and perhaps different sensors again. So we're both capable of being agnostic and working with any drone, and it makes that operator experience common.
Thanks for that, Paige.
Not only that, maybe to add just one small sentence, it can also fit to off-the-shelf drones, let's call it, which are not necessarily came from the platform manufacturer like that, but as a, let's call it, aftermarket kit for some type of drones that you can put it there and still be connected to your back office system, which is another interesting capability.
Great, thank you. I see another question that came in via the chat that I'm just going to go ahead and grab. What happens if there's a loss in connectivity or a malfunction? Is there any risk mitigation built in?
Yeah, so it's part of the certification process, and that's differs between different regulatory authorities. But basically, what L-Site provide is the most reliable communication link. Having said that, there might be places that is still no communication at all because something very odd happened. And in those places, the certification requires, or the regulatory authorities require to have all the safety measures of what happened when you have a connection loss, what happen when you have something happen to one of the motors. So there is different type of scenarios, let's call it, that you need to have answer to as part of your systems design or system engineering. Communication loss is one of them. But again, like I said, looking from our standpoint, that's what we do basically, making sure that to reduce this number to almost zero. I will never say complete zero because it's not something we're working on public infrastructure and very challenging stuff can happen. But from our experience using systems like the Halo, that's what provides you the assurance that you'll be connected as long as it's possible, and that's give you a very high level of SLA, very high SLA. Yeah.
Great. What industries does L-Site work with, Yoav?
Industries in terms of in terms of different segments in the drone environment, we're working with every type of use case and application, all the way from military, homeland security, commercial, everything in there, including inspection, mining, agriculture, etc. Last mile logistics, we have a lot of customers that are doing last mile logistics, both in healthcare and other places, like you heard in the video by Justin from Sprite. So we're really across the board in drone. When it comes to drones, everything but hobbyist drone, which is not our market. We do also have not only that, but we also doing other type of remote moving devices like ground vehicles and others, which is probably for another webinar, but that's a part of what we're doing as well, having ground vehicles or basically any moving device that require high reliable communication. We found that we have a very strong value proposition in those areas, in those markets.
Thank you for that. I'm still going to wait for a couple of minutes and see if some additional questions come in. In the meantime, is there anything else that you think is important for the audience right now to walk away with from today's webinar?
Maybe I'll go first. I think I'd just like to emphasize the reduction in risk for you to adopt these technologies. Both companies have been around for a long time. Both companies have proven track records of working with their partners. So if you really want to de-risk your operator experience and de-risk your connectivity, then this is an integrated solution that you can adopt.
Yeah, I'm 100% agree. And I will add to that that you need to have a good decision. In the end of the day, as decision maker, our work is to make decision. And one of the important decision is who are the partners and who are the right partners to work with. And just like Paige mentioned, you want to have people that have the experience and have the understanding of how operation can be and how it should look like, and to give you value basically from the first call, not necessarily when you start using the actual software or product, but also from the understanding, just speaking with people that have the experience, accumulated a big experience, so many different type of use cases, applications, configurations, and others, and develop some best practices of how to do it. And I'm not saying that it's necessarily us or someone else, it's just making sure you choose the right horses for courses, because in the end of the day, it's a marathon. Going through all the needs and develop it, it's a long time, and you need to think ahead who is the right partners you want to run with. I think that's a great takeout.
Great, thank you. We have received a couple of requests for the slide deck, so I just want to remind the audience that yes, we will send these out within the week. So good ask. All right, well, if there are no other questions from the audience, I have a few just closing remarks. I want to thank Paige and Yoav for their time today. It's been a good conversation. Seeing the videos, seeing how the technology is working is always really interesting. And I know that this sparks a lot of good questions from our community, and hopefully a lot of good follow-up. So attendees, you will receive a link to access the webinar recording within the next week. Another exciting feature is that all of our webinar recordings are now available on AUVSI's learning and engagement platform, Able. So if you want to come back and watch this again, I encourage you to do so. Sometimes when I listen to a webinar a second time, I'm able to pull out pieces that I missed the first time. When you receive the viewing link, there's going to be additional information about accessing that recording and the slides in Able. But please reach out to our team if you have additional questions. You can reach us at any point in time at education@auvsi.org. Lastly, today's program is copyrighted by AUVSI with all rights reserved. Thank you, Paige. Thank you, Yoav, again. We appreciate your time today, and we look forward to hosting you in the future.
Thank you very much for the time, Keely.
Thank you, Keely, and thank you, Yoav, for joining us.
Thanks, Paige.